All right, so here in this video, we are going to look at compound inequalities. So compound inequalities, what they are is essentially just regular inequalities, but compounded, meaning that there's two inequalities at the same time. But we solve these like any other inequalities, and we graph them like any other inequalities, but we're just doing two at once. Now, the thing about this is that there's going to be two types of compound inequalities that we look at. We're going to look at the and inequalities, and we're going to look at or inequalities. And you'll see what I mean by those when we get into it. But those are the two main differences between the compound inequalities we look at. There's an and inequality, and there's an or inequality. So, for example, this right here is what a compound inequality looks like. It's 2 is less than x. It's less than or equal to 6. So you can see the two inequalities kind of put together. You have that one right there, the 2 is less than x. And you at the same time have x less than or equal to 6. So you're saying those two things at the same time. Now this is one of those and inequalities, as we mentioned, because x is in between the 2 and the 6. I can say that 2 is less than x and x is less than or equal to 6. So what I'm saying is I'm saying there's a number that's greater than 2, but it's less than 6. So it's in that region. It's somewhere in between 2 and 6. And when we graph it, we graph the two inequalities together. So if I were to graph 2 is less than x, that's saying x is bigger than 2. I would have the open circle because it's not the equal to one. It's just the less than. So I have the open circle, and then because x is bigger than 2, you're shading that open circle in this direction. And if you look at the other inequality, x is less than or equal to 6, okay, well, you have the equal to portion on your inequality there. So that's why we would fill in that circle. And since x is less than 6, we're going to be shading the x's that are less than 6. And you can see that those two meet in the middle, which is why that entire middle region is shaded. So we're saying an x is a number that's bigger than 2 and it's less than 6. So therefore, x is a number somewhere between 2 and 6. So let's try to do this one. Graph all real numbers that are greater than 0 and less than or equal to 4. So let's write it similar to how this was written over here. Because if we read the words, we'll notice it's an and inequality. That are greater than 0 and less than or equal to 4. So how we're going to do this is we're going to say, okay, 0, and that we're graphing the real numbers. This is our x. X is our real numbers that are greater than 0. So x is going to be greater than 0. And x is less than or equal to 4. So essentially what this says is that we're picking a number, some number between 0 and 4. It's bigger than 0, but it's less than 4. So this is what a compound inequality will look like. At least this is what and inequality will look like. And inequality. Oop, not a Q. That's a Q. All right. So something about this I just want to mention, that these signs are always going to be pointing in that same direction. They're all going this way. All right. You'll never see signs be like this. You'll never see them both be this way unless it's flipped, in which case you will just have to, flip both of these over so that you get what you want. You'll have to flip the whole thing around, but you'll see when we get there. There's a problem like that. But they should, in standard form, always be pointing in the direction they're currently pointing, where you're starting with the smallest number on the left and the biggest number on the right. And it only makes sense, right? Small is going to be smaller than this, and big is going to be bigger than this. So it should always go from the small to the biggest with the signs pointing in that direction. For and inequalities, that is. For and inequalities. Now, if we were to graph this, we would have a number line with 0 on it, number line with 4 on it, and we would have an open circle at 0 because it was just greater than. It was not greater than or equal to. I will have a closed circle on 4, though, because it is x is less than or equal to it. So it's got that little equal to portion. So it's going to be shaded in. And x is bigger than 0 and it's less than 4. So it's somewhere between 0 and 4. That's another good point to mention about and inequalities, is that the and inequalities are always in between. Okay, you're going to shade in between. Because you're saying a number is bigger than another and also at the same time smaller than another in that order. So it's going to be between two numbers. So yeah, you can see it says that right there. And cases have variable in between two numbers. The graph, therefore, is in between two numbers. So the variable is in between two numbers, and the graph is the same way. The graph is all shaded between two numbers. Now let's talk about an or inequality. Okay, the other type of inequality. Graph all real numbers that are less than -1 or greater than 2. Now it's an or inequality because these x values are not going to meet in the middle. These x values are separate, and you'll see that on the graph. They do not overlap. They do not intersect. So we're saying that it's either to this region or it's to this region, but there's no middle ground. They don't meet. There's no x values that both would have in common. So it's either here or it's here, which is therefore why it's an or inequality. And you'll see what I mean when we look at that graph. So in this case, we're graphing all real numbers. And remember, all real numbers, that's our x. X that is less than -1. So x that is less than -1 or that is greater than 2. So or x is greater than 2. So now these inequalities we don't write as a compounded as we do the and, because remember when we did the and in the last problem, we wrote it kind of together, you know, where it was all sort of one ginormous inequality just kind of sandwiched, right? Well, here we can't actually sandwich these two. We actually write both of them just separately, and we separate them with an or. So it's very obvious to tell the difference between an and inequality and an or inequality. First and foremost, because the or inequalities will literally say the word or between them. The and inequalities, they don't say the word and, but they're always going to look like, you know, a sandwiched inequality. So and inequalities will look like this. Or inequalities will, you know, say the word or and look like that. So that's how we write the or inequalities. We just kind of wrote each one separately. We wrote x that is less than -1, and then we had x that was greater than 2. So we got them both. Now when we graph this, we're going to see, okay, here's -1, here's 2. X is less than -1, so it's an open circle at -1, and we're shading the less than side. So x is smaller. The smaller digits would go to the left. Remember, number lines always go from smallest to biggest. Okay, so there's that's the x less than 1 right there. Less than -1. The other one is x greater than 2. So again, open circle on 2 because it's not greater than or equal to, it's just greater than. And all the x values that are bigger than 2 would be to the right, so it would be this direction. So this is what I meant earlier in the fact that they go separate ways. It's or because either x is in this region or it's in this region. We said and before because remember and was shading in the middle, and it's and because both sections overlap. So it's in this one and this one that's the same region regardless. So that's why it's called an and inequality that goes in between. This one's called an or because it's either in this region or it's in this region. Those regions are never going to overlap. They're never going to intersect. It has to be in one or the other. It cannot be in both. There's no x value that can be in both shaded regions for this problem because it's an or problem. The x value is either here or there. It cannot possibly be both. There is no overlap. All right, there's your graph, just like I drew it. Let's erase this just so you can see what this says. Or cases have two separate answers and are solved separately, but on the same number line. Okay, so when solving and cases. So here's an and inequality, but it's an actual it's a problem. We have to solve this. It's not solved already. We can't graph that because we don't have the x by itself. So remember, this is just two inequalities put together in one. You have this inequality here, and let me use a different color to illustrate my other point. Let's say, and you have this inequality here. So I have the one wrapped in red and the one wrapped in blue. If we look at the one wrapped in red, right, it looks like a normal inequality. If I want to solve for x, what I would do is I would add 8 to both sides, right? And I would get rid of the 8, and then I would have that 3x to solve for, right? So I would solve it like a normal inequality. And if I look at the blue side, right, if I look at what's wrapped in blue, and I'm ignoring this, then if I'm trying to solve for x, I would add the 8 to both sides, right? Get rid of that minus 8, and then bring down the 3x and be able to solve from there. So you'll see that both of these actually end up having the same first step. And it's because they're essentially the same inequality. So what I'm going to do is the fact that we have kind of two inequalities together, we kind of have three sides to the equation. Normally we have two sides, right? But here we have three sides. So if I ignored this, right, and I were just solving this, what I would do is I would add 8 to both sides, correct? But if I ignore this and I'm just focused on this, I would still add 8 to both sides. So what we're doing is we're just going to do all of it together. Your goal, essentially, when you're seeing problems like this, is you want the x all by itself in the middle. So we have to get rid of the minus 8. We have to get rid of this 3. And to do that, we have to do it on all three sides. So to get rid of the minus 8, as we've mentioned, we will add 8. But I'll add it in the middle just so it cancels, but I'll add it to the left side and the right side. I have to add it to all three sides because I'm essentially doing two equations at the same time. So negative 2 plus 8 is 6, less than or equal to 3x, less than or equal to 18. So I just simplified. You'll notice that the minus 8 is no longer in the middle because I added it. I was able to get rid of that minus 8 in the middle. But now I've got to get rid of the 3 in the middle. So since it's being multiplied to x, I simply divide by 3 and I can cancel it out. But of course, just like anything else I do in algebra, if I do it to one side, I have to do it to both. In this case, all sides. So if I divide the middle by 3, I better divide the left and right side also by 3 to keep everything balanced. So that will turn this into 2. We'll have x all by itself in the middle, and that will turn to 6. And there's our answer, and we can graph that answer. From 2 to 6, it's both closed circles because they're both less than or equal to signs. And remember, it's an and inequality. X is between 2 and 6, so we're shading in between 2 and 6. It's bigger than 2 and less than 6, so it's somewhere between 2 and 6. Okay. Here's that graph one more time. So an OR inequality, this is a little more work because you can't actually solve both at the same time. You kind of have to solve both separately, but it's really not asking too much of you. You just have to solve basically two problems as one problem is all. So let's focus on this one on the left first. We're just going to solve for x. So to do that, I need to get rid of the 1. I need to get rid of the 3. So we're getting rid of the 1 first because I can't move the 3 that's attached to the x until the last step. So that means the minus 1's got to go. So I'm going to subtract 1 on both sides here. Again, I'm not touching this inequality yet. I'll get to that one later. I'm only focused on the one on the left. So by subtracting 1, that 1 will go away. So I'll just have 3x. And 4 minus 1 turns into 3. So now I got to divide by this 3 to get rid of it because it's 3 times x. Division is the opposite of multiplication. So I'm dividing by 3 to cancel it out. We have x all by itself less than or equal to 3 divided by 3, which makes 1. So that's the left inequality. Now we're going to focus our attention on the right inequality. So on the right, we do the same process, right? We need to get rid of this 2. We need to get rid of this minus 5. Since the 2 is with the x, I have to do that one last. So I'm going to get rid of this minus 5 first. So the opposite of minus 5 is plus 5. So that will cancel it out. That will undo that. So we'll have 2x greater than 12. And then again, just like 2 is being multiplied to x. So if you divide by 2, you cancel that out. We have x is bigger than 6. So there's your OR inequality. You have x is less than 1 or x is bigger than 6. if you put this on a graph, here's 1, here's 6. X less than 1, it's an open circle on 1, and we shade less than. That's the left side. And x is bigger than 6 means it's an open circle on 6. We shade the right side because it's bigger than 6. So again, or inequalities will go opposite ways. Or inequalities will always go opposite ways. And inequalities will always be shaded in the middle. So that's something to keep in mind. And, your graphs will always be shaded in the middle. Or inequalities, your graphs will always be shaded opposite directions. So just keep that in mind. Oh, that was the graph of the last problem. Okay. So I just want to mention real quick about negatives, right? So if you were to solve this problem, you have the negative with that x, and you have to get rid of that negative in order for that x to truly be by itself. So if you ever run into this, you would divide by a -1. But you have to remember that anytime you divide by a negative with inequalities, anytime you divide by a negative, you flip the sign. So the sign would go this way and this way, both sides, because everything flips. Anytime you divide by a negative, it flips. If you look at previous problems, we divided by positive numbers. Like we divided here by a +3, we divided here by a +2. But if at any point we divided by a negative instead, we would have had to flip our sign. So that's what's going on here. Here we're dividing by a negative so that I can cancel this negative out and have a regular x, but that's going to make sure that it's going to flip all these signs. So we'd have -2 divided by -1 turns into +2, and 5 divided by -1, which turns into -5. So now this whole thing is backwards. You have the small number here on the right, and you have the big one here on the left, and the signs are pointing the wrong way. So what we can do is just kind of flip-flop this whole thing. So let's flip-flop it. We would have -5 be the smallest number here on this side, put our signs back the right way, and have 2 be the big number on the right side. So now this is the exact same thing as this, except it's basically just reversed. You can still see that the -5 is smaller than the x, and the x is smaller than the 2. And that's still the case here. Everything just flipped around because this is more standard than this. So don't get freaked out if this happens and your signs flip like this. All you have to do is just sort of, flip everything over. So we'll see that in our last example. Our last example here. Okay, we're going to first deal with this -2, and then we'll deal with this negative here on that x. So to deal with the -2, you would add 2 to all sides. +2, +2, +2. That makes 0 here, less than or equal to -x, less than 1 + 2, which is 3. So just like before, I've got this negative still with that x because it's still there from up above. So to get rid of a negative, remember this is essentially -1 times x. So that's why we divide by -1, because that negative is secretly a -1 being multiplied. And of course, the opposite of multiplying by -1 is dividing by -1, which is what we're doing to cancel that negative out. So then when that happens, the left side doesn't really change. 0 divided by -1 is still 0, but the sign does flip. My x is there. The sign flips over here as well because you're still dividing by negative, and it becomes -3. So again, this whole thing is backwards, right? 0 is actually a bigger number than -3. So it's written the wrong way because remember, it's supposed to be the small number here. The signs go this way, and then the big number here. So everything's just backwards. We just need to reverse this whole orientation. So we're going to have -3. We're going to make sure our signs are pointing the right direction, and then 0 on the end. So you can see -3 is smaller than x, and x is smaller than 0. So we do have everything exactly as we wanted. The signs are pointing the right way. -3 is the smaller of the two numbers. -3 is smaller than 0, so the small one's over on this side. Bigger numbers over on this side. It's kind of weird to say that 0 is the bigger number, but it is, because obviously a negative number is smaller than 0. But there is that. So just be very aware when you have to divide by a negative, you have to flip everything around, but you can just reorientate it. That's a word. All right, I'll leave it there. I'll see you guys in the next video. All right, hope that helps.